Hello, builders and hackers. I am Zaryab, smart contract lead and core dev at Push Protocol. This is going to be a detailed workshop video where we understand what exactly are push smart contracts and how do they function. And along the way, we will also learn some important concepts like what are fee pools, how does the V2 staking algorithm works, or let's say what's the 1271 support that push communicator contract offers. Uh, this is going to be more of a code walkthrough video, by the way, where we dive into the code directly and then form our mental models of how the protocol works. So yeah, let's get right in. What you're looking at right now is the Push Smart Contracts GitHub repo itself. This has the latest version of the smart contracts. So if you scroll down, you should see brief readme about what the smart contracts are. You will see addresses of where they are deployed. And if you scroll further down, you should see an installation guide and setup guide as well. So feel free to clone this. Once you do, you will see this folder structure. Uh, Within the contract folder, you should see push core and push comm contract, and that has all the contracts itself. In case you want to play around with the test cases, feel free to go to the test file, which is here, and then the V2, which has all the smart contract test cases for the version 2, and then it's divided further into core and comm. So before we dive into the code itself, I think it's important to get a brief idea of what these two contracts are. So the entire protocol is divided into two different smart contracts. The first one is called the push core and then push communicator contract, aka push comm. Uh, it's important to note that push core contract is the main lead contract, which includes all the important functionalities like channel creation, staking mechanism, handling the funds and incentive mechanisms and all those things. And push core contract is only deployed on Ethereum and no other chains. While the COM contract is a lightweight contract, which is designed in a way that it can be deployed on multiple EVM chains and in future non-EVM chains as well. This protocol, this smart contract basically includes simple features like opting into a channel, sending notifications, adding delegates for your notifications, and so on. And recently, we also added incentivized chat feature as well. So we will dive into all those things, but it's important to note that push core contract only lives on Ethereum, while push com contract is designed to be deployed on multiple chains. For now, it's just EVM chains, but we are moving on non-EVM chains very soon as well. All right, so let's dive into the code directly now. What you're looking at now is the push core folder itself. It has a bunch of different contracts to begin with the core admin and the core proxy. One thing to note here is that push core is an upgradable contract which uses ERC 9067 for the upgradability. So you will see a proxy contract as well. And so far there has been three different versions of push core that has been deployed: V1, 1.5, and version 2, which was recently deployed. So you need to come all the way down to push core V2, and that's where you see the latest version of the contract. It's kind of easier to navigate because every function in this contract has NatSpec annotations, which explains what this function is, what it does, what it returns, the parameters it accepts, and all those things. So it makes it very easier to read. The most important part of the functions that we will start with is the create channel function. So this is the first function, or I should say the core function of the push core V2, uh, because that is what allows you to create a channel or set yourself up in the protocol to start sending notification to your users and then do a bunch of other things. So before that, just a quick glance of what channels are. So any user or service or product or protocol that wants to activate themselves as a service to send notification or communicate with their users, they are supposed to create channels first of all on the push core contract itself, right? Uh, One thing to note here is since the core contract is only available on Ethereum, every channel must be created on Ethereum. But that doesn't mean the channels cannot send notifications to other chains, because we have something called channel alias, which can be set up for any channel, and they can enable their channel to send notification on different chains as well, like Polygon or BSC. More of this is already available in the doc itself, so you feel free to read from there. Uh, One wallet address can only create one channel in the protocol. At any given point of time, any channel can have one of these four states. It can either be inactive, which basically means it has not been created yet. It can either be activated, which means it is created and it is functioning very well. It can be deactivated, which technically means that the channel owner himself or herself deactivates their channel for the time being, or it can be blocked, which can be done by the push on-chain governance itself. So the community can decide if they want to block a channel completely. So this is to penalize the bad actors. And the last point is every channel creation requires 50 push token uh, to create the channel at least. And if you look at the function, it has a parameter called amount, which allows you to pass the amount of tokens you wish to deposit when you create a channel. This should be at least 50, but you can deposit as much as you want. Now, the important part that we want to discuss in this workshop is what happens to these funds that enters the push core contract. How is this fund divided into the pool funds and pool fees, and then how we take these pool fees to then create an incentivization mechanism for all the users of the protocol. So that's going to be the interesting part of this workshop, and that's what we will explore now. All right, so if you actually look at the create channel with push function, which is the main function that allows you to create channels, it's actually pretty simple, but we will do a quick walkthrough. So it accepts the parameters. The first checkpoint that it has is that the amount should be greater than the minimum channel fees required, which is 50 push, as I mentioned. Then it checks that channel state should be inactive. So any activated channel cannot be created or again. So it basically means a channel can be created only once. And then it does a bunch of other checks on the channel type. So we have different type of channels. Let's say you might want to create a simple channel or a time bound channel, or in future also a token gated channel. Then it emits out an event and it calls an internal function, which is the create channel function. Now this is the interesting part, because what this function does at its core, it just updates the state of what the newly created channel is all about. So what's the state of the current channel being created, what's the pool contribution that it has, what is the channel type, when was it created, the start block of it, and the channel's weight, right? So these are just state modifications. But what's important is to understand how does these 50 push token that came into this contract with the channel creation, how do they get adjusted? So for that, focus on this one. So there is something called a pool fee amount, a channel pool funds, and protocol pool fees. So these three state variables are the main ones to understand how these incoming funds are handled, right? So if you go to the core storage contract, which mainly includes all the state variables, at the very bottom, you should see a couple of state variables that are specifically designed to track the incoming funds in the core contract itself, right? So just let's take a look at all of those. So we have, let's say 1, 2, 3, 4, 5 different state variables. The first one, channel pool funds, protocol pool fees, add channel main fees, fee amount, and main pool contribution. So let's begin with the fee amount first. Fee amount is basically the state variable which keeps track of what's the current fees that will be charged for any important actions. So it should be noted that any fees that is charged in the push core contract is through the push token itself, right? And currently the fee amount is set to 10 push token, and we will see when our fee is charged. But just to give an idea, currently it's set to 10 push token, but this can be changed anytime the community wants it to change via on-chain governance, which we will launch soon. And this gives power to the community to decide what should be the adequate value for the fee amount that should be deducted by channels or by bad actors for doing anything bad on the protocol or anything like that, right? Channel pool funds, on the other hand, this state variable is specifically designed to store the incoming tokens during channel creation. So this one keeps track of all the push tokens that are claimable by the channel owner whenever they deactivate the channel. So this is the state variable that is simply storing the amount of push token that can be claimed anytime back by the channel creators. So if I am a channel owner, and let's say I create a channel uh, on the protocol and I deposit 50 push, what essentially happens is 10 push is the fee amount that will get deducted out of the 50 push. So that 10 push goes to the fee pool, and then the 40 push remains in the channel pool funds, which is basically for me. And whenever I deactivate the channel and I don't no more want to use the channel, I get those 40 push back, right? So that's what channel pool funds does. And protocol pool fees is basically designed to track all the incoming fees in the core contract itself. So it doesn't matter where it comes from, but any fees that is charged uh, within the core contract, it is stored in the protocol pool fees state variable. And this is the core player in how the incentivized mechanism works and how the staking algorithm works. And we will get to that later. But first, uh, yeah, let's see what all are the different ways as of now for the protocol to earn fees, right? So the first one is channel creation, obviously. So if you go to the Push CoreV2 itself and you go to create channel with push, what you see is whenever someone creates channel, we basically have the pool fee amount, which is 10 push token, and then we see what's the pool fund amount, and we basically say that, okay, whatever amount was deposited by the channel creator, just subtract the fee amount, which is the 10 push, and the remaining ones can be stored in the pool funds for the channel creator. So whatever amount you use for creating a channel, 10 push tokens out of that amount goes into the pool fees. So every time a new channel is created, the protocol earns 10 push tokens, right? So that's how it earns the fees via channel creation procedure. But that's not the only way the protocol earns fees, right? So there are a couple of other ways as well. And let's go down a bit. So we have something called a channel state cycle. So remember we discussed what are the different states of a channel. So it can be inactive, which is not created. It can be activated, which is, let's say, the moment after you create the channel, that's activated. It can be deactivated, blocked, or it can be reactivated as well. So these functions allow the channel state cycle to be updated. So whenever there is a channel which is an activated state, but the owner decides to no more use it, so he can deactivate the channel. Once he deactivates, the channel goes back to an inactive state, and he gets back the 40 push token again. But if the owner decides to reactivate his channel, he will again have to deposit some sort of push token, which is the minimum required, at least the minimum required push token, which is 50 push. And then again, whenever someone reactivates their channel, the protocol earns the pool fee, which is again the small amount of 10 push token, right? The other way to earn push token as fees is when someone does a channel update, right? So if you go to this, yeah, so update channel meta is basically a function that allows the channels to update their details. So let's say if a channel's logo or description changed or title changed, they might want to update it. For example, if a channel rebranded to a different name, so they can use the update channel function, and using this, they can update their channel description. But when they do it, they will require to pay some sort of fees, and that's just another way of how the protocol earns fees. And then there is notification setting creation. So there is one more function which allows the channels to create notification settings for their users, and you can read a lot about it here in the NetSpec itself. But this is just a way for channels to create different notification settings, and we will be releasing this feature on the dApp itself very soon. But this is another way of how, whenever you want to create settings or you want to create multiple settings again and again, the protocol does charge a small fees on that one as well. And the last one, as of now, is the time-bound channel destruction. So if you notice on the channel creation function itself, there is an additional parameter that was introduced in v1.5, which is channel expiry time. So previously, whenever you created a channel on Push protocol, that channel was permanent. So you could not delete that channel. You can definitely deactivate it, but that didn't serve the purpose of creating temporary channels. So if there is an event which will last, let's say, for for 7 days, or there's a hackathon of 1 month, you just want to create a channel to notify your users for just that month. You don't need that channel to remain on the protocol forever. And keeping that in mind, that there will be a requirement for temporary channels to be created, we included additional parameter, which is the channel expiry time, which basically allows users to create a temporary channel for a particular duration, and after that duration is over, the users are supposed to deactivate or destroy their channel. However, in case they fail to deactivate the channel even 14 days after the expiry, the push admin can deactivate it, and if the admin deactivates it, they will charge some sort of fees. So just to give an idea, these are couple of ways by which the push protocol, the push core contract charges fees in different mechanisms, and all those fees are stored in the protocol pool fees itself, right? Now, why did I mention that pool fees, this protocol pool fees state variable is a core player in the incentivization mechanism? That is because all the fees that is stored in this state variable, it will eventually be distributed as rewards to all the users of the protocol. So if you look at it here, we introduced a stake and claim mechanism in the core V2 itself, and that mechanism basically relies on the protocol pool fees itself, which essentially means that the more the protocol grows, the more fees it earns, the more rewards are there for the users or the stakers who are staking their push token in the core contract, which in a simple line, the more the protocol grows, the better the incentivizations for the users who are using the protocol. So there is a direct relation between the protocol growth and the incentives for user of the push core contract itself. All right, so now that we have some idea of how the pool funds and pool fees work at the push core contract, let's do a quick recap to understand all the functions that we have covered so far, and then move to the most interesting part, which is going to be the V2 staking, which uses these fees as incentivization for other users, right? So let's start the quick recap. So to begin with, we understand now that channel pool funds is the state variable that tracks all the incoming funds for channel owners. So if I'm an owner and I deposit 50 push token, 40 push token is what's stored in the channel pool funds, and 10 push token out of those 50 push tokens goes to the pool fees. So whenever I deactivate a channel, I can basically claim back those 40 push token that is stored in channel pool funds. Protocol pool fees is basically there to track all the incoming fees, all the fees generated by the core contract itself. Add channel min fees is a state variable that basically indicates the lowest amount of push tokens required for creating channels. As of now, it's 50 push token, but again, this can also be changed based on the community's decision. Fee amount is currently set to 10 push token. This is basically the amount that is charged as fee every time there is some sort of request of a particular feature by channel owners, or there is a bad actor who needs to be penalized. So these fee amount is used in all those scenarios, and every fee in the protocol is paid in push token itself. Min pool contribution is basically the minimum amount of push tokens that is required to be stored in the protocol by every channel, right? As of now, it's just one push token. All right, so let's do a quick recap. We now know that update channel meta basically allows users to update their channel's details like description, logo, title, or any of that sort of thing. Basically, if you look at create channel function, there is something called bytes identity, which is basically a package of all the important details about the channel. So it is basically a bytes that has the channel's name, description, logo, details, etc. And what happens in update channel meta is basically we tell the users to pass the new identity bytes with the new details of the channels. And the moment they do that, we basically emit it out as an event, and that is then stored in the DB. And when someone does it, we basically charge some sort of fees. The protocol charges some sort of fees, which is stored in the protocol pool fees. Then we already understand what create channel function allows us to do. It allows us to pass expiry time as well now. So we are able to create time-bound channels which can expire after a particular set of time. After the channel expires, channel creator is all free to go and destroy this channel. and get back the push token. However, if they miss and they do not destroy it for, let's say, more than 14 days after expiry, the push owner can also come in and they can destroy the channel and they get to keep part of the fees as well. Then we covered channel notification setting creation. So this function allows channel owners to create the notification settings for their channel. This can be a slider type or Boolean type notification, but it basically is a way for a channel to provide custom, for a channel owner to customize the way they want their users to interact with notifications, and it just adds on better features for the users to use the channel creation, channel notifications. And again, if you want to create channel notification settings, it also charges some sort of fees. Then we have the state cycle functions, which basically allows to change the states of a particular channel, right? So a channel can be in active mode, but in case the owner wants, he or she can deactivate that channel as well. When someone deactivates the channel, if you look at this, the channel state goes back to 2, which basically means the channel state is no more in the activated state. Then you see that whatever the total pool funds of the channel is, that is refunded back to the channel owner, and then basically the channel is deactivated. And once deactivated, it cannot send notifications or it cannot use it for any other purposes. But the deactivation is a temporary procedure, so you can reactivate the channel anytime you want. And when you reactivate, the protocol charges some sort of fees again. And that's basically the minimum amount of fees, which is 50 push tokens. Once you reactivate it back, the channel state is changed to 1, which is the activated state. The channel's weight and the channel's pool contribution is again updated, and the protocol charges a fee amount of 10 push token. Then there is a block channel as well. So for every bad actor in the protocol, there is a way to punish them through block channel itself. While as of now, it's under the push channel admin to decide. It still happens through an on-chain voting. And this will basically be shifted to the community itself, where they can decide which channels they want to block. When someone blocks the channel, as you can see, all the pool funds basically go to the pool fees itself, right? And the channel state is basically updated to 3, which basically means the channel is blocked and it cannot be that particular address cannot be used to create channel again on the protocol. Then we have some very small functionalities which basically allows to verify a particular channel on the protocol. Once a channel is verified, there is a verification badge that appears in the UI as well, and that's just a better way to recognize the channels that have a good reputation. And yeah, these are the functions that were there in the core V1 and V1.5. But now what we will explore is the core V2 stake and claim functions. And this is where we included a major change, wherein all the fees that was generated by the protocol, now with the stake and claim, there is a way for users or for push holders to earn incentives with the push protocol as well, right? And let's explore how that works. All right, so now we come to the most interesting part of the core smart contract, which is the staking algorithm. So if you look at the brief history of push smart contracts, with version 1, we launched the pool funds. With version 1.5, we launched the pool fees, which is a way for the protocol to generate and store fees in the contract. But with version 2, we launched a major feature which allows the protocol to not just store the fees, but also distribute these fees among all the push holders. So we will dive into the code a bit later, but before that, it's important to get some basics clear about the staking algorithm. So in a nutshell, a staking feature basically allows the push token holders to stake their push into the core contract and earn rewards directly from the fee pool itself. The first point to note is that this is the epoch-based staking. So understand it in a way that the entire staking duration is divided into epochs, which is a predetermined slot of time. And each epoch is 21 days long. Users can stake at any epoch they want, and the distribution of rewards is split into these epochs within which the user can stake and earn. One of the important part that I would like to highlight is this one. So with Core V2 staking, one of the cool features that also went live was the push tokens time weightage feature. Uh, what this essentially means is, unlike any regular ERC20 token contract, push token does not just track the amount of token that you hold, but also it's capable of tracking since how long have you been holding it for, right? And based on that, we are able to calculate the weight of a particular holder. So if someone has been holding push token for a very long time, their weight will be more than someone who is holding it for a very less time. If you look at the push token contract itself, which you can also find in the same repo in the tokens folder, uh, there is something called a holder weight mapping, which basically keeps track of the block number when you got the push token and since how long have you been holding that push token, right? And the reason I want to highlight this is because this plays an important role in the algorithm as well when we decide how much reward one should get. Um, so yeah, just keep this in mind and we'll get back to it later again. So coming to the next point, it says total claimable rewards at an epoch relies on the fee pool, which essentially means that for any epoch, the reward that we calculate, it directly relies on the fee pool. And fee pool is basically an indicator of how much the protocol earned in that particular epoch. So let's say in epoch 5, if the protocol generated or accumulated a lot of fees, so there were a lot of channel creations, there were a lot of uh, channel reactivation or updations or any other transaction that made the protocol generate a lot of fees, in that epoch the fees generated by the protocol will be very high, and people who are staking in that particular epoch will get higher rewards. So it's just a simple way of looking at it in a way that for any epoch where there is a lot of fees accumulated by the protocol, the rewards go significantly high in that particular epoch. So the more the protocol earns in a particular epoch, the more rewards stakers of that epoch will receive, and the less the protocol earn in a particular epoch, the less the stakers of that epoch will receive the rewards, right? Um, by the way, as a staker, you can stake for as long as you want. So you can be a staker since epoch 1 till epoch 10, 20, or 28, whatever. And when you finally harvest, we basically calculate your claimable rewards in every epoch. So maybe some epoch had higher rewards and some had lower rewards, but you will get whatever you deserve based on your token weight, your holder weight, based on the epoch rewards that was generated in that particular epoch. And we will see the exact formula that we use to calculate this. But these are a couple of important points to remember before we go into understanding the code. It's an epoch-based staking. Distribution of rewards is split into epochs. Every epoch is 21 days long. We do consider not just the token amount of a holder that one holds, but also how long they have been holding it for, and we reward according to that. And rewards rely on fee pool of a particular epoch, right? So if you come back to the core V2 contract itself, at line 744, you will see that all the staking and claiming functions start from here. To begin with, there are a couple of helper functions that we use in the algorithm. So I'll just zoom in a bit. So this is the function that allows us to get the token weight of a particular holder. So like I mentioned, we are able to track how long someone has been holding push token for using the push token contract itself. And this function allows us to get that. So what we need is the address of the user, of the holder, the amount, and at which block are we trying to get this weight in, right? And using the holder weight mapping, we are able to get the exact holder weight of that particular user, right? Last epoch relative is just a way for us to calculate the current epoch, the current active epoch, based on the block numbers that we pass, right? If you want to see the state variables for staking, simply go to core storage V2, and then you should be able to see all the state variables structs that is being used for a particular, for the staking algorithm itself. So we have the user fees info. For every user, there are details that we store. The staked amount, what is the staked weight, when was the last staked block, when was the last claim block, and then we also store epoch to user staked weight, and we will see why we store this in a minute. Uh, then we have different state variables that we also use to keep track of different things. For example, Genesis epoch keeps track of when the staking starts. Um, Epoch duration is basically 21 days long. Each epoch is 21 days long. We have a mapping, which is called epoch rewards mapping. This mapping basically holds the epoch rewards present in a particular epoch. So it will basically be like at epoch 1, there is 100,000 rewards available. At epoch 2, there is 50,000 rewards available. And whenever we calculate the claimable reward for a particular user, we do consider this. We do check how much reward is present in that particular epoch. And based on that, we calculate how much reward should one particular user get. And again, we will see the formula of how we calculate reward in a minute. And yeah, so these are state variables that we use for the staking algorithm. So directly, let's jump into the stake function first, right? Couple of simple details about stake function. Push token holders can stake their tokens at any given time. There is no starting or end time for a particular staking. Push has time weightage built in. This means that holders who have held push token for a longer time are rewarded more. And the longer they stake, the more they are rewarded, right? So if you look at the staking function itself, what we basically do is, first of all, we calculate the user weight. So this is basically to track for a given address and for a given amount, what exactly is the weight of that particular user. And then we do a token transfer from the user's wallet to the core contract itself. After that, we update some important states for that particular user who is staking. So staked amount, what's their last claim block, which will be 0 initially. And then basically we also call the adjust user and total stake function. So there are two important helper functions that are called for every imperative transaction like staking, unstaking, or reward harvesting. And those two important functions are, first is it's called adjust user and total stake, and second function is called the setup rewards and weights, right? So I'll just go briefly about what these functions do. So the first function, which is the adjust user and total stake, is basically called every time any important event happens, which is staking, unstaking, or harvesting, because this function is responsible for tracking the fluctuating user weight whenever they stake or they unstake. So if someone stakes, their user weight will go high. If it goes high, at what epoch does it go high? So we need to keep track of all those things. Or if someone unstakes, it will go low, it is decreased, and we need to keep track of that. So adjust user and total stake is designed to do that. It mainly handles, for example, 3 different cases. The first case is when the user is staking for the very first time. At that particular instance, it's pretty easy. We just assign the staked weight with whatever user weight is being calculated. So if you remember, in the stake function itself, we first calculate the user weight, right? I can zoom in a bit if you want. This user weight, and like I previously mentioned, this plays an important role because eventually when we calculate reward for a particular user, we do have to consider their weight, their holder weight. And holder weight is not just about how much token you hold, but since how long have you been holding it for. So when someone stakes, we do calculate the user weight, and then we pass the same user weight in this function, in this helper function, which is that just user and total stake weight. So this function basically includes 3 different cases. The first case is, let's say a user is staking for the very first time. It's pretty simple. We simply add the staked weight, the user weight into the staked weight state variable, right? Second case is, let's say the user stakes again, but in the same epoch. Again, this is pretty simple because we can simply update the user's staked weight of that particular epoch, right? The third case is a bit tricky, but this is mainly to handle a scenario where the user stakes again, but in a different epoch. So let's say I staked first at epoch 2, and then I go and stake at epoch 6 again, right? How will this be handled? So it basically uses a for loop to keep track of when I staked last, so which is epoch 2, and what's the current epoch, which is epoch 6, right? So it then runs the loop, and for all the epoch except from the current epoch, so if I stake last at epoch 2, then epoch 3, epoch 4, epoch 5 will basically get the same user staked weight like I had previously, but epoch 6, which is the current user, which is the current epoch, that will be updated with the current user weight that is increased actually with the staking that I just did, right? So these three cases are mainly handled. The first is if I stake for the very first time, it's pretty simple. I just update the staked variable for my staked weight. If I staked again, so let's say I staked once in the epoch 2 and then I staked it again, my epoch weight for that particular epoch will increase, and that's okay. For a scenario where I staked once at epoch 2 and then I staked at epoch 6, for every epoch in between epoch 2 and 6, we basically have the same user staked weight that I had in epoch 2. And then for epoch 6, it basically gets updated with the current user weight that is being passed. So this is, in a nutshell, what adjust user and total stake does. In simple terms, it basically just keeps track of the user's weight based on any imperative action that they do on the protocol. If they stake, unstake, or they harvest, we do call this function to make sure that at any given time, the user's weight is always updated adequately. Then set up epoch rewards and weight. This function is responsible to update the epoch reward mapping. So remember we discussed there is a mapping that keeps track of what exactly are the rewards for a given epoch, right? And this function is the one that updates that. So if you look here, epoch rewards mapping is basically updated in this function based on a couple of conditions. But the role of this function is whenever someone stakes or unstakes or harvests, this function again is called every time. And the core functionality that it performs is basically it checks the current epoch, and then it checks, hey, is this epoch's reward updated or not? So if the current epoch is 2, do we have rewards attached for 2 or not yet? If there are no rewards attached for 2, which basically means that epoch rewards at 2 is 0, which technically means that anyone who is taking at epoch 2 will not get anything. So it's this function's responsibility to always check whenever it's called what exactly is the current epoch and whether or not the current epoch has rewards attached to it. If not, it attaches it. If it's already there, it just skips it. And then it updates the total weight, which basically will be used in the calculation of the reward for a particular user. So these are the two helper functions that we have. And again, you can go through the NatSpec annotations to understand better, play around with it if you want. But in a nutshell, this is what it does. Okay, so back to staking. Staking in this algorithm is pretty simple. You can stake whenever you want. When you stake, your token holder weight is considered, and then we store and update the states accordingly. Now, if we come to how rewards are calculated, which I think is the most interesting part. So this function in the contract is responsible for calculate epoch rewards. And what it basically does is actually pretty simple. So at any given time, the rewards of a particular user basically is calculated based on 3 important parameters. The first is the rewards at that particular epoch. The second is the weight of that user in that particular epoch. And the third is the total staked weight of that particular epoch, right? So how much rewards are present for that user to be claimed in total. So how much reward is present in epoch n, let's say, in total. Then how much is the user's weight in that epoch, and how much is the total staked weight in that epoch. So the user A, let's say, is not the only staker in epoch n. There are multiple stakers. So we calculate the user A's weight, and then we calculate the total staked weight in that particular epoch. We divide those two things, and then whatever we get, we multiply it with the total rewards available at epoch n. So it's pretty simple. And once we do that, we know that, okay, for a particular user, let's say address 0xabc, who had a weight x, will get reward y, because we are able to calculate uh, the percentage of reward that the user deserves based on their weight. And their weight is basically related to not just how many push tokens they have been staking and how long they have been staking, but also how long they have been holding push tokens. So this is what makes this algorithm really interesting, because we're able to reward early holders, we're able to reward early stakers, and it's not just based on how much tokens you stake, it's also based on how long have you been staking for. So this is how the rewards are calculated. And again, calculate epoch rewards is the function that you might want to see if you want to calculate the amount of reward that a user will get at a particular epoch. All right, so now that we understand how staking works, how the helper function works, and how reward is calculated for any given user, it's time to understand the unstaking part. So unstaking is pretty simple. It basically allows you to withdraw the tokens, but there is an interesting part here as well that must be understood. Uh, by default, there is no lock-in period when you unstake, so it's never like you have to stake for 5 months or a year to get your rewards. It's not like that. So people or holders are free to unstake whenever they want. However, there is a delay period uh, of at least one epoch before which a user can harvest or withdraw, and there is a reason for that. So if you look at the unstake function, I hope you can see it clearly. Yeah. So if you look at the unstake function, the very first checkpoint basically says that you cannot unstake before one complete epoch. Why is that? Why is this delay period? So if you remember, each epoch is 21 days long. So it doesn't matter if you stake at the very first day of a epoch or at the 20th day of a epoch. It is still considered as epoch 1, right? Uh, which basically means that it's not going to be fair if someone stakes at the very end of any particular epoch and then claims rewards as if they staked at the very first of day of the particular epoch, right? So let's say epoch 1 started, user A has been staking since the first day of the epoch, while user B just staked at the 20th day, and both user A and B are getting the equal rewards. That's not fair. So this delay period is to ensure that no matter when you stake in a particular epoch, you stake at the very earlier days of a particular epoch, or you stake at the very later date of a particular epoch. It doesn't matter. What matters is once you stake, you need to ensure that you stake for at least one complete epoch before you can unstake your stakings from the contract. And that way, even if you are getting rewards equally, so let's say now if user B is getting equal reward as user A despite staking at the 20th day of epoch 1, it is still fair because we know that user B cannot withdraw their staking before completing one complete epoch, which again user A will also be completing. So this is a way to penalize bad actors from misusing this procedure of getting rewards, because like I said, we don't want to include any lock-in period. You don't have to wait for a particular duration to get rewards. You can get rewards right after you are capable of it. But just to make sure this is a fair game for everyone, there is a delay period of at least one epoch. So if you are staking at any particular epoch, at any particular slot of the epoch, doesn't matter if you're staking at the very earlier time or at the later time, you will, once you stake, you cannot unstake it till one complete epoch, and you finish one complete epoch, and after that you can unstake whenever you want. So this is something that must be understood about unstaking. Apart from that, there is one more checkpoint which basically says that you can only unstake if you have staked. So it's just a straightforward checkpoint. Once we know that the user is a valid staker with this checkpoint, and then we know that the user is not staking without completing one complete epoch, and we know that both of these checkpoints now pass, then the user can come in, and whenever you stake, all your pending harvesting, all your pending rewards can also be fetched. So when you unstake, you don't have to call the harvest function separately. You can call it's being called right from the unstake function itself. And after that, again, we call the adjust user and totally stake function, because like I mentioned, this is a function that is called for any important change that happens in the contract regarding user stakes. So it's called in unstaking as well. And after that's done, we basically mark it all as 0, and we remove the total staked, we decrease the total staked amount, state variable from the contract as well. So that's just unstake and how unstake works. All right, now that we understand how staking, unstaking, and reward calculation works, it's time to get some idea about harvesting as well. As the name suggests, harvesting is basically allowing users to claim their rewards for all the epochs that they have been staking in. So first we'll go through some basic points of harvesting, and then there is an interesting point that we must keep in mind, and then we'll look into the code as well. So as we already discussed, the more the protocol accumulate fees at a particular epoch, the better the rewards are for the stakers of that epoch. Uh, Essentially, harvesting functions allow you to claim rewards for all the epochs that you are a part of as a staker, right? Which essentially means the longer you stake in the core V2, more rewards you are eligible to claim, right? Understand it this way. So let's say you have been staking since epoch 1 to epoch 50. You are basically making yourself eligible for all the rewards that the protocol earns for from epoch 1 to epoch 50. So you will get part of those rewards, right? Because you have been staking since 1 to epoch 50. And since your rewards are directly tied to how much the protocol earns, the longer you hold, the more the chances of protocol earning more fees, generating more fees, and the better the chances of you generating more yield on those fees. So that's what harvesting function allows as well. However, let's come to the interesting part now. Uh, Rewards can never be harvested for the current epoch that is active as of now, right? So now let's look into the code and get some idea of what I mean by it. So by the way, there are different functions that allows, it just makes it easier for people to claim, because there is one function called harvest all, which will allow you to claim basically for all the epochs that you have been staking in so far. However, harvest paginated is a function that allows you to claim till a particular epoch only. So let's say if you have been staking for 20 epochs, you can choose to claim only till epoch 5 or epoch 10, and you can, it just provides you an option of how you want to claim rewards. So if you look at the core harvest function, it takes in the user's address, the person who is claiming, and then it takes in the argument called till epoch, which basically means till what epoch does this user wants to claim his rewards, right? Now, the important part is these two checkpoints. So the first checkpoint says the current epoch should always be greater than the till epoch, which means that you can never claim for the current epoch itself, right? Because that's ongoing right now. So for instance, if a user has staked at epoch 1 and now it's epoch 6 and he wants to claim at epoch 6, he must be aware that he cannot claim for epoch 6 itself. So what he can claim till is from epoch 1 till epoch 5, right? But not epoch 6, because that's currently active and it's going on. So the contract doesn't allow anyone to claim for the current ongoing epoch itself. So that should be kept in mind. And that's the first important checkpoint that the harvest function includes, right? So current epoch must be greater than the till epoch, so you cannot claim for the current epoch. And then it checks that the till epoch should be greater than the next from epoch. So it's not very intuitive of what it means, but it technically means the next from epoch, which basically means when did the user claim last. From that epoch onwards till the till epoch is something he can claim for. So if I have already claimed 2, I cannot claim 2 again. I can start from the next from epoch, which is 3, till the till epoch, let's say, which is 5th, right? So considering the same example, if I'm a user who staked at epoch 1 and now it's epoch 6, but I already claimed at epoch 2 once, right? So now I can just claim for epoch 3, epoch 4, and epoch 5. I cannot claim the current epoch. I cannot claim the epoch that I already claimed for, right? So these two are the main checks that harvest function includes. Once we know that both of these checks pass, we just come and we just start initiating the for loop, which basically allows us to claim for all the epochs that has been unclaimed yet, and then we add all those rewards, and those rewards are transferred to all the users. And that's what I said. So the more epochs you have been staking for, more your rewards, because it basically adds all the rewards that you are eligible to claim because you have been staking for so long. uh, and yeah, that's pretty much it. After that, we basically update the amount of reward a particular user has already claimed in a particular mapping, and then we update the last claim block again, because as we see here, last claim block plays an important role in deciding which block you will claim, which epoch you will claim again next. So we update that, and that's pretty much it for the harvesting function itself. So what we just covered is staking, unstaking, reward calculation of how it works in CoreV2, and then how harvesting works in CoreV2. We understood some of the important rules. For instance, you cannot unstake before completing one complete epoch in the CoreV2. In case of harvesting, you cannot harvest for the current epoch itself, and you cannot harvest for an already claimed epoch, right? So these are a couple of rules that the protocol, that the smart contract includes. And that's basically how the staking algorithm works in the Core V2. All right, so now that we have understood Core V2 contract completely, it's time to take a brief glance at Push Communicator contract as well. As previously mentioned, this is designed to be deployed on multiple chains, which is why it's comparatively much simpler, lightweight, and it's also very less reliant on Push core contract. Couple of important features that it has, it's like subscribing to a particular channel, unsubscribing from it, sending notifications, or adding delegates for a notification, and recently include feature in V2, which is incentivized chat feature. So we'll just take a couple of minutes to go through each of them. The Push Comm contract itself can be found in the Push Comm folder, and because this is also an upgradable contract, you will see some proxy files as well. But the file that matters the most is the latest version, which is Push Comm V2. Once you are in the file, this is the send notification function that we have, right? This is really interesting because it allows you to trigger on-chain notifications as well, which could be of a great use in multiple use cases. If you look at the check notif requirement, so this is a list of checklists that the send notification function imposes. And only when we complete this checklist are we allowed to send notifications, right? So the first checkpoint says that the message.sender for any channel which is 000 should be the push channel admin. Then it says that any notification that is triggered should always be from the channel owner itself. So this is the channel's address, and only if the channel address, which basically means the channel owner, is triggering the notification himself or herself, that's something that's valid, so we can allow that. But there is one more checkpoint which says delegated notifications is also allowed. Now, what's delegated notification? It basically means that me as a channel owner can allow any other wallet address, let's say 0xabc, to send notification on my behalf, right? So adding delegates is basically a way for channel owners to delegate their power of sending notification to any other address they trust, and then that delegate address can send notification on behalf of the channel. All right, moving forward, we also have the 1271 support feature of the COM contract, which was introduced in the version 1.5, which basically means now the contract has the capability of not just verifying any EOA signature, but also a contract wallet signature, right? So if you look at the send notification by signature function, there is additional code snippet that basically checks if the given address is an EOA, externally owned account, or a contract. And if it's a contract, then we basically use the 1271 to validate the signature. Now, this makes it very easy for smart contract wallets like Argent or Gnosis Safe to be included and use the COM contract, because signature verification is now possible. Next up is the incentivized chat request feature, which was recently introduced in the version 2 of the protocol. This basically introduces a really effective way for users to customize the experience by implementing a one-time fee in push tokens for whoever wish to send them push chat requests. So for instance, if I am user A, I can enable my chat settings in a way that anyone who wish to talk to me using push chat will first have to send some sort of minimum amount of tokens that I require, right? So it basically allows users to not just use the push chat feature, but also monetize on top of it. And yeah, these are a couple of features that we have in the communicator contract itself. The incentivized chat request feature will be launched on the tab soon as well. So yeah, hope that helps. All right, folks, so that brings us to the end of the workshop video. I hope now you're able to create some sort of mental models of how push smart contracts work, how the core and communicator works, how the V2 staking algorithm works, and so on. The GitHub is always open, so feel free to create issues and PRs there. There is a open bug bounty going on as well with Immunify. So in case you find issues, you can report it there as well. And reach out to us on Discord in case you want to discuss more on the push smart contracts. Thank you.